Welcome to Eagle's Concept Learning Room. In this video, we're going to take you through circle theorems in mathematics syllabus D. So circle theorems, these questions, they always appear in your paper 1 mathematics. So we are going to explain the theorems using examples from various past paper 1 questions. So to begin with, we're going to explain the parts of a circle. A circle has got several parts. The first one is a diameter. So a diameter is simply a line that passes through the center of the circle and divides the circle into two equal halves. So half a circle is known as a semicircle. Any other line that touches one point of the circle to the other is known as a chord. Alright, so half a diameter is also called a radius. It doesn't matter where it passes as long as it is from the center and it touches the circumference. From the center, it touches the circumference, or it can even be there going that side, or from there going that side. As long as it's from the center to the circumference, then it will be called a radius. Alright, so that is about the radius. Then we also have a tangent. This is a straight line that is drawn outside the circle and it only touches one point of the circle. That one is called a tangent. Okay, in this second diagram here, we have what we call a minor segment. Now, a minor segment is an area that is bound by a chord and an arc. Now, because there are two areas that can be bound by a chord and an arc, is what we call a minor arc and is what we call a major arc. So a major arc is the one that is bound by a chord and a major arc, which would be called a major segment. Then a minor segment is the one that is bound by a chord and a minor arc. All right. Then we've got an area bound by two radii and a minor arc being called a minor sector. Then two radii and a major arc, that area which is bound by these is called a major sector. All right, let's look into the circle theorems themselves. So there are about 8 of them, and they are not listed in any special order, but as long as you are able to memorize the 8 of them, then you are warm and dry. So number 1, the theorem number 1 says the angle in a semicircle angles in a semicircle adds up to 90 degrees. Now, what does it mean? So if you have a diameter like that, then from one end of the diameter to the other, if you just draw two lines, they are meeting somewhere, then that angle will be what? 90 degrees. Let's take, for example, if I draw a line from there to here and from there to here, meaning this angle that has been formed here is 90 degrees. Or if I get from there to there, this angle that has been created is also 90 degrees. Or if I get from there to here, as long as these two lines are touching the ends of the diameter and the circumference, at any point it will still be 90 degrees. Even if we get from there all the way up to there, this one will still be called 90 degrees. So that is what it means. So as long as you can recognize this one, it's going to help us in our calculations. Okay. The second one simply states that the angle at the center is twice the angle at the circumference. Now, the angle at the circumference times 2 will give us the angle at the center. And please note that it should be on the opposite. If it is this side, then it's that side. If, for example, we drew something like this, then we have an angle here at the circumference. Then this angle x, name it x, then it is going to be twice. Times 2 of that one will give us this one. So this one is going to be 2x. That's what it means here. So let's always follow that one. So when we say the angle at the center is twice the angle at the circumference, let's make sure that we go for the opposite. So this one and this one and this one and this one. All right. Then the third rule here simply says the angles in the same segment are equal. Or in short, angles that are coming from the same chord. Let's label this chord here A, B. So this is a chord, okay? It's a line here that has been drawn here. This dotted line, it's a chord. So angles that are subtended from the same chord are equal. Now we call these that angles in the same segment, all right? Angles in the same segment. Now, which segment are we talking about? All this area here is a segment, and they are subtended from the same chord. So this is how come we're saying this angle and this angle are equal. Even if we had to do something like this, let's say we put this angle there, then we come here, they are both coming from the same chord. Okay, let's take for instance, I name this one X, I name this one Y, I name this one Z. Then if I write this one, notice something. I'm going to write this angle X here, it will be called A, angle A, X, B. Okay, please, I want you to notice something. Then the second one will be A, Y, B. Okay, so we have A, Y, B. Then this one we are going to have A, Z, B. Okay, so A, Z, and B. Okay, I want you to notice something. So the first letter and the last letter are the same. The first letter and the last letter are the same. So it means that in this scenario here, these angles that are in between are the same because they are coming from the same segment. So this is one trick that you can use just to notice those angles, because sometimes you won't have any need to calculate, but just to recognize these rules. Okay, let's look at the third rule. We are saying the opposite angles in a cyclic quadrilateral are equal. Now, a cyclic quadrilateral is a four-sided polygon that touches the four sides that exactly fits inside a circle. So, if any four-sided polygon that fits inside a circle is called a cyclic quadrilateral. Okay, so now what we are saying is when we add this angle and this angle, the total should be 180. When we add this angle and this angle, the total should be 80. Now, what it is, supposing we didn't know this angle, then they've given us X. So if we want to find this one, we're just going to use the fact that this one, 100 here, we're going to use the fact that 100 plus X is equals to 180. So 100 plus X is equals to 180. So we can work this one out. We are simply going to say X is equals to 180. Then this one crosses, it will be minus what? Minus 100. And here, this one is going to give us 80. So that's what we mean here. So opposites, this one and this one are opposite, this one and this one are opposites. All right, let's look at theorem number 5. This one says the angle between a radius and a tangent is 90 degrees. So in short, what we are saying is a tangent and a radius, it makes an angle of what? 90 degrees. So the point where a radius and a tangent meets is always what? 90 degrees. Okay, let's also look at number 6. So this one they are saying the outside angle, which the angle between a chord and a tangent is the same as the one which is the opposite inside the triangle. So this one and this one, that one and this one are the same. So all these things are going to be applied as we deal with the other things inside. All right, so number 7, we are saying the tangent to a circle from a stem point will be equal. So this one and this one, they are both tangents. So meaning the distance from there to there and from there to there, they are the same. So that's what it means here. So these tangents are the same, they are equal. All right. Then the radius through the midpoint of the chord will bisect the chord at 90 degrees. Okay, and that is what they are talking about here. All right, so these are the 8 rules, 8 theorems that you have to know about. And let's see how we can apply these ones now in solving the questions. All right, so the first sample question reads, in the diagram below, A, B, C, and D are points on the circumference of a circle center O. DAT is equals to 40 degrees, BDC is equals to 30 degrees, and AT is a tangent to the circle. So now, when they say DAT, they are talking about this angle. When they say BDC, this is BDC, they are talking about this angle. So the middle letter is the angle that is in question here. I'm sure we all know that by now. All right, so now a little tip before we can dive into the calculations. In order for you to successfully answer circle theorem questions which appear in paper 1 only, as in the new curriculum by ECZ, please, you need to bear in mind, you need to have the ability to identify the triangles. then you couple it also with some properties of angles. For example, supplementary angles, which are angles on a straight line, add up to 180. Angles in a triangle add up to 180. Then also you know about angles on an X, you know about the isosceles triangles, the equilateral triangles, and so on and so forth. That knowledge is going to help you to swiftly answer such questions. So please have the ability to recognize triangles within the question that you have been given. All right. First things foremost, let's try to fill in as many angles as we can before we can actually even answer the questions as we have been requested, and also make sure that you show all your necessary working. All right, so in here, I've been given this angle here. Okay, now this angle, when I look at it, it is coming from this segment here. So this is BDC. Okay, so BDC. Now, BC is the segment. So BDC. I also have BAC. So this angle here, BAC, this angle BAC is actually 30 degrees. Now, how do I know? The rule simply says angles obtained from the same chord and in the same segment are equal. So if you check here, this is B, D, C, and then me, I'm saying also B, A, C, these two are equal. I'm sure you agree by now. These two are equal. From the explanation, we are saying B and C. Also here we have B and C. So it's the same chord here. Only the middle letter is different. If you find such a situation, then you know that the angles are the same. So I know this angle here is what? 30 degrees. All right. Then I also see that OD, this one is a radius. OA, this one is also a radius. So this one now, this shape AOD, it has given me what we call an isosceles triangle. So an isosceles triangle has got two sides that are the same, and the base angles, they tend to be what? The same. So the angle which will be here and the angle which will be here will be the same. So now, when I look at this radius and the tangent here, from there, all the way from there up to there, should give me 90 degrees. But since they've given me 40 already, so I just have to say 90 minus 40. Okay, so 90 minus 40. This 90 minus 40 should be able to give me what? 50. So meaning the angle for here is 50 what? Degrees. If that be the case, then even the angle for here is also 50 degrees. So now, in a triangle, angles add up to 180. So I'm adding 50 plus 50, which is 100, plus this x is equals to 180. So this one will simply be x is equal to 180 minus 100. Okay, so this one will give me 80 degrees. Okay, so meaning the angle for here is 80 degrees. So that when I add 80 plus 50 plus 50, it should be 180. Then look at this BOD. This is a diameter, meaning it's a straight line. So angles on a straight line also add up to 180. So when we add x plus 80 is equals to 180. So x will be equal to 180 minus 80. This one will give us what? 100. Anyway, let me write this one. What I said is x plus 80. This one is equals to 180. So now this 180 here, if I want to find the value of x, it will simply be equal to 180 there minus 80. So that is how I found my what? My 100 degrees. So I found my 100 degrees here. Now this 100 degrees here, if I subtract also I add, because this is a radius and this is a radius, meaning the angle there and the angle there should be the same. So automatically here I'm just going to say 180 minus 100. Yeah, so I'm just going to say 180 minus 100. Okay, so this is 100 here. So here I'm going to say x plus x, which is 2x. So this one will give me 2x plus what? Plus 100. This one is equals to 180. Okay, so this one will be 2x is equals to 180 minus 100. So meaning 2x here is equals to 80. Then I divide by 2. Even this side I divide by 2. So that one goes, this one and that one goes. So I'm going to have here 40. So that is 40. So meaning this angle here is 40. Also, this entire angle there is what? Is 40. Okay. So that is what we are having. All right. Let's see with what we have found here if we have answered some questions. So here they say BD. So this is B. This is CBD. C is C B D. Okay, so now CBD we haven't yet found. Now look at this one. BOD, this is a diameter. So a diameter will divide this one into a semicircle. So BCD, this one BCD, this one is actually what? A 90 degree here. So this is 90 degree. So meaning we're just going to add 90 plus 30, which will give us 120. Then 120 minus 80, this one will give us also 60 degrees. And we have found our angle. So what I said is BCD, this is a triangle. So when I add this angle here and this angle here, remember, whenever you join a line at the end of a diameter and another end, when everywhere they join, they form 90. So we have this 90 and this 30 adding together, which will give us 120. Then we subtract minus 180 to find this one. This is how come we're finding the 60 degrees. So this angle here is the 60 degrees. Okay, then BAC. So this is this angle CBD. So CBD. Okay, we have found. Then BAC. Here we have found also this one is what? 30 degrees. Okay, so BAC is actually 30 degrees. Then we are going to find what? AOB. So this one is AOB and that one is 100 degrees. And we have answered all the questions appropriate. So this one is what? 100 degrees. And we have answered the question. So please be very good and have foresight of identifying what? All the rules that we have looked at. In the diagram below, PR is a diameter of a circle with center O. Q and S are points on the circumference. The tangent to the circle at the point P meets QS produced at T. PQS is equals to 26 degrees and QPR is equals to 42 degrees. Okay, so first and foremost here, what we have to find is, let's find what we can find. We've been given this angle here, 42 and 26. So we're going to add 42 and 26 plus this x here. Let's name this one x because remember, angles on an x, okay? Angles on an x, they are the same. So this angle here, if this angle here is x, then even this angle on the other side is what? Is x. Meaning if this one is y, even this one is also y. So that is the rule that they follow. So now what we can do is we can use this one. We can just add there 42 plus 26, okay, plus x. This one should be equal to 180. Okay, so we use this one. Why? Because this is a triangle now. This has become POQ, it's a triangle. So we add 42 plus 26. Okay, so 42 plus 26, let's add that one. 42 plus 26, just add it from here to simplify things. So 42 plus 26, this is 8, this is 68. Okay, so meaning x will be equal to 180 minus 68. Please show your working. So minus 68 like that. So let's subtract 180 and never write your things here. This is the examiner's use. So me, I'll just use it because it's my rough paper for now. So 180 minus 68. So 180 minus 68. We subtract that one. So this is 68. Okay, and this is a 10 there. So this remains 7. So 10 minus 8, that is 2. 7 minus 6 is 1. So we have a value of 112. So meaning this one here is 112. Even this one here is also 112. That's what it means. Okay. So if those two, this one and this one are 112, so we can just multiply this one times 2. We're going to have something like a 4 here. 2 times 1 is 2. then 2 times 1 is also what? 2. So we have 224 like that. So 224 plus 2x. So we are having something like 2y. Okay, 2y. We now want to find this one and this one. So 2y plus 224. 224. This one should be equal to 360. Now, why 360? Because this one has become a complete what? Revolution, a full circle. And a full circle is up to 360. Okay, so this one becomes 2y is equal to 360. Okay, 360 minus 224. So minus 224 here, we have minus 224. So this one here, this is 5. Then we have our 10, 10 minus 4. 10 minus 4, that is 6. Okay, then 5 minus 2, that is 3. So we have 136. Now this 136, this is 2y is equals to 136. So divided by 2. Also here divided by what? By 2. So that one cancels. Okay, then 2 here, 1. 2 here, 6. Remainder 1. Then 2 here, it's 8. Okay, so meaning our angles, this one here is 68, and this one is also 68. Okay, so we have found that one. Now, another thing that can be found here, we already know they've told us that this is the circle center O, so meaning this is a diameter here. So when we join this point and that point, this point and that point, this whole angle here, from there all the way up to there, it gives us 90 degrees. But since we have been given a 26 here, so to find this other side, we are simply saying 90 minus 26. Yes, so 90 minus 26. This is 10, this is 8 there. So here we have 10 minus 6, 10 minus 6, that is 4. Then 8 minus 2, that is 6. So this, our angle here is 64. All right, so since we have found that our angle as 64, then we can now find, PRQ. So let's see, PRQ. Now they are saying PRS. Let's see, PRS. They want us to find this angle here. Okay, they want us to find the angle PRS. Okay, so PRS, this one is PRS. Let's see, this is PRS. This is the one that we have here. Okay, now that is from PRS. So which code are they using here? Okay, right now we cannot use any code. Let's see, how about PRQ? Have we found PRQ? So PRQ, we can easily find PRQ here because we know that this is 90. So this one is simply going to be 90 plus 42. Okay, 90 plus 42. Now I'm looking at this triangle here, from there to there, all the way up to there. It's a triangle. Then we have this side, we have this side, we don't just have this one. That's why we are adding 90 plus 42 plus the x, which we don't know, which should be equal to 180. Okay, so this one, 90 plus 42, let me just add it like this, so that I have a 2 here and I have a 132. Okay, so my x will be 180. Okay, 180 minus 132. So 180 minus 132. So this is our 10 here, and this is our 7. So 10 minus 2 is actually 8. Then 7 minus 3 is actually 4. So we have 48. So this angle here is actually 48. All right, so we have found that angle, which is PRQ. So our PRQ is equals to 48 degrees. Then the next angle they want us to find, PTQ. So this one we have found already. It's 48. So please, you look for these things. You look for these things. You check. What does this mean? Then PTQ. Let's check now. PTQ. All right. So now PTQ. So here, if you check here, there is something that they're saying. So ROP, this line here is a radius, is a diameter, but from here to here, it's a radius. So radius and the tangent, this one here already, it gives us what? 90 degrees. It is a rule. It is a rule. One of the rules. Remember, one of the rules that we read, it says that the radius and the tangent makes 90 degrees. So which means here we are going to add 90 plus 42. Okay, 90 plus 42 plus this 26. Then so we add 90 plus 42 plus 26, which is giving us 158. So meaning to find this angle here, we are simply saying 180 minus 158. Okay, minus 158. And the value here is going to give us 22 degrees. So we have found this one, 22. And okay, we have found all those. So there is only one angle that is remaining. So this one is 22. So the only angle that is remaining is actually PRS. Okay, PRS. All right, let's try to think of a rule that we can use if we want to find PRS. So we are finding this angle here, which is what? PRS. Okay, so we check. We had found something here. We have 42 here. Okay, so we have 42. If this angle is 42, it means that even that angle there is 42. Okay, why? Because we know that this one will be RSQ, then this one will be RPQ. So even this one is the 42, and then this angle here is the 112. So the only one missing is this one. So we can easily say 112 plus 42. 112 plus 42. Add this one. We're going to have a 4, and this is a 5, and this is 154. Then we subtract 180 minus 154. Minus 154. So what value are we getting here? This is here is okay 180. So this is 7. Then this one becomes 10. 10 minus 4, that is 6. Then 7 minus 5, that is 2. Okay, so we have our answer as 26 degrees. So this answer here is 26 degrees. All right, so please, the rules are supposed to be combined. So you look for which rule is making sense on this question so that you can sort it out easily. Okay, let's look at this one now here. So this one, for a start here, they're saying in the diagram below, points A, B, C, and D are on a circle. BD is a diameter of the circle. AC is equals to 42 degrees. CAD is equals to 33 degrees. And the lines AC and BD intersect at X. So this one they've given us is the diameter. So if this one is the diameter, we can easily find this angle here, because we know that the entire angle here is 90 degrees. Remember, from one point and one point, wherever they meet is 90 degrees. Okay, so we can just begin. We subtract there. This is 90 minus 33. So 90 minus 33. This one here, we're going to have, this is our 8. That is 10 minus 3. That is 7. Then 8 minus 3. That should be 5. So we have this one as our 57. Okay, then the next thing that we're going to have is, this is also 90. All of it here is 90. So when we say 90, okay, this one we are saying 90 minus 42. 90 minus 42. This one we are going to have, this is a 10 here. So this is 8. Then here we have 8. So, okay, so this is 90. So we remove 1 there. It remains 8, 8. So this is 48. Okay. So this is 48 degrees there. All right, so this is what we have. Okay, this is what we have. Then having that one, there is something also that we can do in order to find these angles that are in between here. Okay, so before that one, we can look at the angle CAD. Let's look at the angle here, CAD. So let's write it like this. CA is to look for the properties CAD. So this is CAD. Now we can also say CBD. Okay, so CAD and CBD. Now someone might be wondering, how am I guessing these things? I'm not guessing. I just looked at this chord here. So this chord is making this angle. Then I checked, okay, this chord it's also making what? That angle there. So definitely I knew, okay, if this is CAD, then this one will be CBD. So meaning this angle here is also what? 33. Okay, so if this angle is 33, then I can easily what? Find that angle there. By doing what? Because I'll take this one BXC as a triangle there. So I'm just going to say 42 plus 33. So 42 plus 33. Then this one here, this is 5. Then 4 plus 3, that is 75. Then I say now 180 minus 75. Okay, so I'll subtract it from here so that you see, because there's no calculator in the paper one. So 75 like that minus, so this also remains 7. This becomes 10. 10 minus 5, that is 5. Then this is 0, and we have 105. Okay, so meaning our angle here is 105. And remember, angles that form an X, they are the same. The opposite ones are the same. So this is 105. Okay, now how do I find the one for here and the one for here? It's very simple, because I know if this is y, even this is y. So y plus y will give me 2y. So 2y plus, then this one is 105, 105. This one will give us together a 210. Okay, so this one is plus 210, and it is expected to give us a value of 360. Okay, so meaning 2y will simply be equal to 360 minus 210. So 360 minus 210, we have a 0 there, we have a 5, then we have a 150. So we divide this one by 2, because this is 2y. So it will be 2y is equals to, so over 2, even that side will be over 2. So this one and that one will cancel, that one and that one will cancel. So we have a 75. So meaning this angle here is 75, then this one here is 75. Okay, so now if we have this angle, that angle, we can easily find all the angles in here. Okay, we can easily find all the angles in here. But before we can keep on wasting time, let's check if we have found most of them. So find CBD. So here they are saying C, this is CBD, that is the 33. So CBD, we've already found this one to be what? To be 33. Okay, then the next angle is ACD. So ACD, which is 48. Okay, 48. Okay, please ensure that you show you're working nicely, not as rough as I'm doing it. Okay, but nicely. Be on the lookout for the video where I'll be demonstrating exactly how to answer paper 1 questions. Right now it's about me teaching the concept. Okay, then AXB. So this is AXB. So we have also found that one as what? 75 degrees. Okay, we are done with this question. The question reads, the diagram below shows a circle with a tangent RWS. The points V, W, X, and Y are on the circle such that XYW is equals to 44 degrees, VWY is equals to 54 degrees, and SWV is equals to 39 degrees. Right. So you need to have the ability to identify the rules or the theorems as discussed. So the first thing that you need is for you to have the ability to identify. You can use the identification of triangles, which becomes very handy in finding angles. But before you can do that, make sure you have the ability and the foresight to see different theorems that can be applied appropriately. So like in this case, we have this one, an angle between a chord and a tangent. So an angle between a chord and a tangent is equal to the opposite inside triangle. So this one, the opposite inside triangle is this one, which is 39. Okay, just in case people are getting twisted, let me just show you where this rule is coming from. So here, this is the rule here, alternate segment theorem. So this angle here outside is equal to that one. That one outside is equal to that one. So this is a chord and a tangent. So that is where it has come from. All right, so this is what we have, this one here and this one there. So once we know this one here, then we also be on the lookout for the chord. So when you see this chord WX here, it has got two angles, this angle there and this angle. So these two angles are coming from this chord. So here we have something like WVX. So we have WVX, and we also have WYX. WYX. Remember what I said? When the first letter and the last letter are the same, then it means that the angles are the same. In this case, the angles will be equivalent to 44 degrees because this one has 44. So meaning even this one is what? Is 44. So now if you find this 44, note that this is just directly opposite. This is directly this one, directly opposite this one, which is an angle between a chord and a tangent. So even this angle here outside is also what? 44. All right. Now that we have 54 and 44, we can easily find this angle because when we add 54 plus 44, so we add 54 plus 44 there, what we're going to have is 98. Okay, so meaning 98 plus this x is equals to 180. So in short, we are saying to find that angle, we are saying it's 180 minus 98. Okay, and the value there we have is this one here is 7. Then we have a 10, 10 minus 2, which is 2, 17 minus 9, which is 82. So here we have a value of 82. And remember, this is an x. Angles on an x, if this one is 82, even this other one will also be what? 82. So we have our 82 here. So meaning to find this other angle that is here, we're just going to say 82 plus this 44 here. So 82 plus that 44 there. This is what you're going to have. So we have 6, then we have 126. So 126, this plus this 126 plus x. So meaning we're just subtracting now 180 minus 126. So 180 minus 126. So this one here will be 4 because here we are saying this is 7 there. Okay, then we have a 10. So 10 minus 6 is 4. 7 minus 2 is 5. So we have 54 degrees. So this angle here is 54 degrees. So to find this entire angle here, we just have to add 54 plus 39. 54 plus 39. So here if we add, let me add it from here. So 54 plus 39, 54 plus 39, we have 3 here, carry 1, then 5 plus 3 is 8, so we have 93 degrees. Okay, so we have answered this question. So we have RWX. So RWX, this one is simply equal to 44 degrees. Okay, then XVW is also 44 degrees. 44 degrees. Then we have the last one here, which is 93 degrees. So this is how you find the angles. There are other methods. If you want, you could have first found this angle so that you use this angle and this angle to find this one. Then you add all these, subtract 180, and you still come up with this value here. But you don't need to complicate your life. Just follow the rules. That is the best thing that you can do, is follow the rules, and then everything else will be straightforward. They're saying in the diagram below, O is the center of the circle, A, B, C, and D are points on the circumference. AD produced meets the line from C at E such that CD is equals to DE, and angle AOC is equals to 120 degrees. All right, so to begin with, as you can look at this one and this one, there's a relationship. So meaning the angle at the center is twice the angle at the circumference. So here, when we divide this one by 2, we get this one, which is a 60 degrees. So this what I'm saying, you'll be showing your working as you do that. For example, you can simply say angle ADC. So ADC, if you are showing your working, you are saying ADC is equal to half, okay, half multiplied by AOC. AOC. So this one will be equal to half multiplied by 120. Okay, half multiplied by 120. So this one also even gives us what? 60 degrees. So this is how you show your working. Okay, then you have found this one. Then here, this other side here, you can find this other side because this one will also help us to find this one. So we are simply going to say 360. Okay, 360 minus 120. So 360 minus 120. This is 0, that is 4, so that is 240. So now, because we know that this angle is twice this angle, so we are going to divide this 240 by 2, so that we get a 1, a 2, and a 0, so it's 120. So this angle here is going to be what? 120. Then to find this angle here, remember, ADE is a straight line, and angles on a straight line are supplementary, meaning they add up to 180. So we are simply saying 60 plus x is equals to 180. In short, we are just going to say 180 minus 60. Okay, so 180 minus 60, this is a 0, this is a 2, this is a 120. So this angle here is 120. If that angle is 120, since they're telling us this line and this line are equal, so we can just say, okay, 120, 180 minus 120, which will give us what? So 180 minus 120, which will give us 60. So 180, let's try it. 180 minus 120. This is 0, this is 6. Then we divide that one by 2, which should be able to give us what? 30 degrees. Okay, so why are we dividing? Because this one and this one are equal. So meaning this one is x, even this one is x. So when we add x plus 120 is equals to 180. When you solve that one, this is where we are coming up with what? With this one. All right, so that is how you solve such questions. Just make sure that you know how to identify the circle properties. Once you can identify that one, everything is simple and straightforward. So this has been circle theorem. Thank you so much for listening. Ensure to subscribe if you are watching for the first time, and you can share the link with a friend. Remember, sharing is caring. Thank you. See you next time.